All right, today, as we heard, we have probability or trig, whatever, the unit circle, sure, inverse trig functions. Now, just like the warm-up, we're basically just working backwards. Instead of me giving you angle and looking for the result, backwards. I'm giving you the result and I'm looking for the answer. So, given that theta is between 0 and 360, what angle does sine of theta equal 1? Anybody got that? 90 degrees is correct. 90 degrees. Nice. For what angle does cosine equal negative 1? 180. Right, where are those numbers coming from? These are quadrantals. Here is 0, 1, where the sine is 1 at 90. Here is negative 1, 0, where the cosine is negative 1. So that's just coming from the quadrantals. Now, when you see it written like this, it's relatively straightforward. You just read the sentence. It could also be written like this. For what angle is sine exponent negative 1, parentheses negative 1. That's asking you sine of what is negative 1? Or the answer to sine is negative 1. What is the angle? It's all the same question that we've answered so far. It just looks a little bit different. What do we think about that? Negative 1 will be 270, sure. Yeah. 270 for sine. And of course, we're pretty much doing the full loop-de-loop here. What angle is the inverse cosine 1? 360. Now, look back to this first question. It says from 0 to pi to 360. So pi has to be between 0 and 360. There are actually two places where the inverse of cosine is 1. One of them is 360. What's the other one? 0. It's actually the same place, but yeah, there's actually two values, of course. We're back to having our answer being degrees, so we know that coterminal degrees all have the same values. So that's why this question clarifies between 0 and 360. Because there's another one, 450. Now where the heck did 450 come from? Sine, it's 360 plus 90. Now, because it does say between 0 and 360, we don't really need the 450. Now this one, 0 or 360, some teachers will tell you, oh, we like 0 better. Some teachers will tell you, oh, we like 360 better. A lot of times if the answer is going to be one of these, it'll tell you something like 0, theta, 360. And then they'll put an equal sign on one of these. And if that's the case, we are allowed to be equal to 0, but we're not actually allowed to be 360. So that's like a really trick question. If you've got a really punk teacher, they might throw that one at you.
Are you a punk teacher, Mr. C?
I guess that's up to you. I try not to be, but just kind of keep your eye out for that. There are multiple answers, which doesn't really normally matter, but for 0 and 360, some people might prefer 0, some people might prefer 360. And so just keep your eye out for maybe one of these has an equal sign, and that tells you you're allowed to use that one, and you're actually not allowed to use the other one. Okay. Now, for what angle does the sine of theta equal 1/2? 30 degrees. 30 degrees is right. Now, is that the only angle where the sine equals 30 degrees?
No.
No, there's another place, and I think you said it, 150. So you actually have two options, and you'll have two options for every value except for the quadrantals, because those quadrantals only have one. But we know that our unit circle has so many matching reference angle buddies that you always have a pair that's the same, right? Sine is positive in 2 quadrants and negative in 2 quadrants as well. So, what that leads us to is an issue of if I ask you for the inverse sine of 1/2 or what sine of what theta equals 1/2, Dory could say 30 and Jabri could say 150 and they'd both be right. And that's annoying for me to grade. That might be a little bit of an issue if we're doing one of those equations. Remember we did those equations like for the warm-up or for the homework yesterday? Well, it's kind of weird if you guys get different answers and they're both right. And then so here's what's going on. Limiting the domain of sine inverse, cosine inverse, and tangent inverse. This is basically teachers just deciding, let's just pick one of these angles, right? Let's just pick one of these as a bit nicer. So, when it comes to sine theta, okay, we like the first quadrant, okay? And when it comes to the second quadrant, where it is also positive, we don't really use that one, okay? So if you have the option between 30 and 150, we like 30. And that makes sense, right? Because 30 is like the most common. We know that 30, 45, 60, those are the ones that we talk about over and over again. And so basically, for all of these that are positive, in that first quadrant, we like those, and they're positive in other quadrants as well, but we don't really like those quite as much. So for cosine, which is also positive in quadrant 4, we don't really ever use those as our answers. And tangent is even positive down here in quadrant 3, but we don't really like that one as much either. So basically, we need to choose one of the two that are positive, and the same exact thing happens with the negatives, right? We need to choose which one of these is a little bit nicer, which one of these works a bit better. So sine is negative down here and down here, and we need to choose which one of these that we like better. Are you more comfortable with the third quadrant or the fourth quadrant? Which one do you think we're going to end up picking here? We are going to end up choosing the fourth quadrant. And I'll explain why we chose that one in a minute. Over here, cosine is negative in 2 and 3. We're going to choose the second quadrant. And over here, tangent is negative in 2 and 4. Now, tangent honestly is the one that students normally struggle to remember a little bit because we chose to use the fourth quadrant for sine and we chose to use the second quadrant for tangent. We're going to end up choosing to use the fourth quadrant for tangent. So, this is actually quite important. Okay, it might feel like Mr. Collier just drew a bunch of random pluses or negatives on the board, but this is important. All of your answers have 2 possibilities, and you need to make sure you choose the one that is in the correct quadrant, okay? The big idea is that we choose that one because it's like the simplest, easiest kind of way to think about it, okay? So, the cosine of 1/2. Well, what is the cosine of 1/2? Well, you get 1/2 at 60 degrees for cosine. And so I can put 60 degrees here. You also get 1/2 at 300 degrees. But again, one of these is the answer, one of these is just kind of, we don't really use that one. And as always, quadrant 1, we like quadrant 1. if you need to be positive, it's always quadrant 1. Period. Right? All of them. Positive in quadrant 1, positive in quadrant 1, positive in quadrant 1. The second one here is cosine of theta equals negative square root 3 over 2. So this one's not going to be in quadrant 1. This is one where we probably need to remember a little bit. Okay? Again, I like to think about how sine of 30 is a nice number and cosine of 60 is a nice number. Then I think square root 3 over 2, that's not a very nice number. So this is a 30 family. It's negative cosine, which happens at 150 in quadrant 2 and happens at 210 in quadrant 3. And when we're dealing with cosine, do we want quadrant 2 or quadrant 3? We want quadrant 2. Now we already said how we always like quadrant 1 and we never like quadrant 3. Quadrant 3 is like too far away from home, okay? So we never are going to choose an angle that's from quadrant 3. The cosine of 0, this is a quadrantal. We've only got one option. You get the answer, you move on. That was one of the questions up there. What is the cosine equal to 0? Actually, maybe there's more than one option. Isn't it 90 and 270, right? Because here we would be 0, 1, and here we would be 0, negative 1. Which one do you think we like better, 90 or 270? 90. Again, we're trying to just choose like the nicest number, the number that we like to work with. What about the cosine of square root 2 over 2? It's a positive number, easy. First quadrant, what's the number going to be? 45. Now for this question, so far, for this whole worksheet, we've done every single thing in degrees, but this also exists in radians too. So let's challenge ourselves to do radians for these bottom 4 questions here. When is sine 1/2 in radians? Anybody got it? Pi over 6. Also pi over 6, but no, we're using the first quadrant, so nice job. Pi over 6 is the answer. When is sine negative 1/2? Okay, so this was not as easy. It's negative in the third quadrant and in the fourth quadrant. We never like the third quadrant. We always are going to prefer to ignore the third quadrant. So we're like in the fourth quadrant.
11 pi 6?
It would be 11 pi 6. Now, again, here's a little bit of an important moment. If you're starting to zone out or if you're watching your Chromebook or something here. Our 2 options that we just had were 11 pi 6 or 7 pi 6. 11 pi 6 isn't really that great, honestly, right? It's kind of a weird number. We don't really like that one either. But 7 pi 6 also kind of sucks. So why do we really prefer the fourth quadrant when honestly 11 pi 6 is kind of gross? Well, another way that we could write this, when does this happen, would be at negative 1 pi 6. Because negative degrees go backwards, and so we would be going down 1 pi 6 to get into this position. We know that 11 pi 6 minus, which is not something we normally do, but if we subtract 12, we would get negative 1 pi 6. So these are coterminal. And actually, negative 1 pi 6 is also, it's not really all that bad either, right? It might even be better than 11 pi 6. So keep your eye out for the negatives getting involved. A lot of times if you do a multiple choice question, you might get, boom, hit with a negative pi 6 for those fourth quadrant values because they're actually a little bit nicer, right? I see sine of 1/2, that makes me think of pi sixths. Then I see negative, I say, oh, well, it's negative pi sixths, and then I'm done. Okay, so actually these negatives end up being something that you like more than you think. When is tangent equal to 1 at 45 and 225, but we were going to choose the first quadrant, and in radians, what would that be? Pi over 4. And then lastly, when is tangent negative square root 3 over 3? I like to kind of think about my cheat code that looks like this. So it looks like tangent would be at 30 degrees or pi sixth, but I need to be negative square root 3 over 3. So I could go with my 11 pi 6, or I could go with negative 1 pi 6, right? Again, what's a little annoying is that we tried to eliminate some of these so that we would only have one answer, but with those negative ones, it's kind of like, sometimes actually there are kind of two possibilities. 11 pi 6, or maybe you might write it as negative pi 6. Maybe he was checking if we were locked up. Come on, Mr. Collier, what are we doing? I guess that was Colin's fault. All right, we've pretty much done these questions. Now, just to make this look a little bit nicer, okay? A lot of teachers won't diagram these the way that I've done it, okay? Some teachers instead will have it look like this, okay? Sine, we like these two. Cosine, we like these two. And tangent, we like these two, okay? Now, we talked about why that is, because sine is positive here, negative here, positive here, negative here, positive here, negative here. We talked about why that was. We kind of, when you see it this way, it takes away those negative options. So if you want to maybe erase on your paper in those and kind of rewrite that maybe a little bit, it's definitely less mess going on. But if you would rather write it like that, that's fine. The bottom line, we don't like that, we don't like that, we don't like that. All right, we're done.